Hi everyone, welcome back to Made Easy Academia. This is another episode, so please don't forget to like our videos, share so that others can be able to benefit from it. So today we'll be talking about balancing of redox reactions, but before that, I will teach you how to name a compound using it to determine the oxidation numbers in a compound. And what is important here, we have oxidation. At the same time, we have reduction. Oxidation and reductions. Just like the matter of that, we know that oxidation is the loss of electrons, while the other one is the gaining of electrons. You'll be wondering, how does this one related? I will teach you very well how to use it and how to even make use of naming a compound. Let's also talk about naming of compound so that it just be like additional to this. Naming of compound. So this naming of compound, we need to know how to find the oxidation number. Or let me first how to firstly find the oxidation number. We know, in case if you missed our previous video, we have already talked about how to identify each oxidation number of each element using electronic configuration. We determine them like either any element from first to nth element. We use that method to determine their oxidation number. For example, maybe they said determine the oxidation number. Determine the oxidation number of X in XO4. So maybe I was asked to determine the oxidation number of X in XO4. So oxidin is O is oxidin. And we know if you use that method I taught you, if in case if you missed that video, just kindly watch it. Oxidin is number 8. We say it's going to be 2, 6. This is K shell, L shell. So this must be 2 and this must be 8. If balance the first one and the second one is not balanced, it remains 2 to balance. So that's going to be -2. So that means here we are going to have X. So oxidin is -2. That's going to be -2. But we can see it has 4 here. That stands for everything is equal to 0. So here we have plus. Plus times minus, we are going to have minus. 2 times 4, we have 8 is equal to 0. Then we have X to be equal to plus 8. Can you see that? So what maybe they said, determine the oxidation number of, they said determine the oxidation number of C in HCOOH. So I was asked to determine the oxidation number of C here. So I know hydrogen is 1, right? It's plus 1. The oxygen I will just mention now is -2. So I want to find the oxidation number of C here. So from here we have plus 1. I'm looking for the carbon. That's plus C. Oxygen is -2. Oxygen again is -2. Then we have plus 1. Everything is equal to 0. So here we can have this result to be. So if I arrange them, that's going to be plus C. So what I have is plus 1 -2 -2 plus 1 is equal to 0. So here I can have this one to be plus C. So 1 minus 2, that's going to be -1. -1 minus 2, we are going to have -3. -3 plus 2, we are going to have -2 is equal to 0. So if I collect like terms, we have plus C is equal to 0 plus 2. That's plus C is equal to plus 2. So you can see how we do that. Okay, it has opened. Now, let's see another ways of doing that and how we can make use of this approach. Then we'll be able to know. So now we can have a radical compound. Maybe if it has a power, how are we going to go with that? If it has a power, it's still the same thing. You don't need to worry about that. If it has a power, it's another way of doing that. For example, it's just the same way rather. So the only difference is instead of equating it to be 0, we equate it to that power. We equate to that power. For example, maybe they say determine the oxidation number of X in look at this one. Determine the oxidation number of X in XO42 minus. You can see it's a radical compound. The only difference between that one is this has a charge, isn't it? So I'll go with that. That's going to be plus X. Oxygen is minus 2. That is minus 2 times 4 is equal to oxygen. These are so everything. Sorry, what we have is as the power is minus 2. That's going to be equal to minus 2. So here we have plus X minus 2 times 4, and we have minus 8 is equal to minus 2. Then plus X is equal to minus 2. This is minus 8. So when it comes here, it's going to become plus 8. So here we have plus X is equal to minus 2 plus 8. Of course, we are going to have plus C. So we'll be using all this method when dealing with our compounds. So let me just give you this logic of this. When oxygen is 1, in general, we use mono. And we have 2. That one is a di. But mostly we use oxide for the 2. When we have O3, that one is tra. When we have O4, that one is tetra. When we have O5, that one is penta. When we have O6, that one is hexa. When we have O7, that one is hepta. When we have 8, that one is octa. When we have 9, that one is nona. And at the same time, if you have 10, that one is nothing but deca. So we have to know this one, please. When it has oxygen, mono, 1 oxygen is mono, 2 oxygen is di, 3 is tra, tetra, penta, hexa, hepta, octa, nona, and deca. You'll be wondering that what's all this? You see the beauty of that. Let's say, for example, I want to determine. So when you have to name a compound, you firstly determine the oxidation number. Like if it is 2 elements, you determine for the first one. If it is 3 elements, mostly you determine for the one you have at the middle. For example, maybe I was asked to find this. Maybe the question says that maybe they said name the following compounds. Let me give examples. Maybe the question says name the following compounds. Name the following compounds. Name the following compounds. 1, CO2. 2, let's say XO. 3, HNO3. 4, K2CR2O7. 5, let's say we have CaCO3. So another thing is, another logic is for the 3 elements, if you have one, the one you have at the middle, for example, this is another logic. If I have nitrogen as the middle, if it is nitrogen, we call it a nitrate. Can you see the logic? If I have carbon, so can you guess if you have carbon? That one is going to become what? Yes, it's going to become carbonate. What if I have sulfur? Sulfur is going to become what? It's going to become what? Yeah, just like the same logic. So this is carbonate, this is sulfate. So the one we have at the middle, just like it's changing its form. Carbon, carbonate, sulfur, sulfate. Even if you have chromium at the middle, it's going to become chromate. So it depends on the approaches. If it is 3 compound, after determining its oxidation number, then mind you, the one we normally use here, we normally use Roman figures, not numbers. So let's say I want to name this compound. I want to name CO2. Maybe I see CO2 for the first time. So what I will do, I will firstly determine the oxidation number of the first one, which is carbon. So now that means that we have plus C. You know, we have done this a lot, that oxygen is minus 2. So that means that we have minus 2, but we can see it has 2 as a subscript. That is times 2. Then everything is equal to 0 because this is not a radical compound. So here we have plus C. Minus 2 times 2, of course, we are going to have minus 4 is equal to 0. So this is minus. When a minus goes here, we have it to be plus. That is 0 plus 4. So that means C here is equal to plus 4. So now, say for the 2 elements, which is compounds, you can see we have 2 elements there. It will not change its form. If you have 2, look at it from here. We say if you have 2, it's di. in general, we can use oxide. So that means if I want to name this one now, C, this is C, that's going to be carbon. What do we get? We got 4, that's going to be carbon 4. So oxygen that we have here is 2, that's going to be carbon 4 oxide. Can you see that? Okay. Let's try another one so that you see the beauty. Okay, let's try the second one as well. We have XO2, XO. So since it is 2 elements, I will still determine for the first one. For this, that's going to be plus X. Oxygen will remain as -2. -2 equal to 0. If I collect like times, I will have plus X is equal to 0. This is -2. When it comes here, it's going to become plus 2. Then we have plus X is equal to plus 2. So if I want to name this, I will have it to be sulfur. What do we get? We have 2. That's going to be sulfur 2. Then we have oxide. So let's try the next one, the third questions. Let's try the third questions. In the third one, you can see it's different because it's 3 elements, which is a compound. So I told you, for this case, if you have 3 elements, the one you are going to determine is the one you have at the middle. So hydrogen is +1. You know that one is general. That's going to be +1. Now I'm looking for N, which is nitrogen. That is plus N. So oxygen is -2. That is a -2. Then you can see that we have 3 at the subscript. Then times 3, everything is equal to 0. So here we have +1 plus N. -2 times 3, here we have -6 is equal to 0. Then plus N plus 1 -6. Of course, we are going to have -5 is equal to 0. So if I collect like times, I will have plus N is equal to plus 5. So if I want to name this compound, this is H. That's going to become hydrogen. So now you don't say hydrogen nitrogen. No. You will name it like this. Okay, hydrogen. So when we have 3, I told you here, when we have 3, 3 is tri. So that's going to be hydrogen trioxo. So I told you here that when we have nitrogen, it becomes what? That becomes nitrate. That's going to be hydrogen trioxo nitrate. What do we have as a result? We have 5. That's hydrogen trioxo nitrate 5. Mind you, for these numbers, it's going to be Romans, not, for example, maybe we have a student that now put hydrogen trioxo nitrate. Instead of writing this one, you now put 5 like this, you get 0. So mind of this, the number you are going to put in the bracket must always be a Roman figures. Now, let's try the next one, then I will give the last one as simple exercises. They said we should try this one. We should name this compound K2Cr2O7. So let's name this one. Let's try this one too as well. So here we have, which element is K from the 4 figure tables? Yeah, potassium. So now, so K2Cr2O7. I told you, if you are given 3 elements, the first thing to be considered is to determine the one you have at the middle, to determine the oxidation number. So now, sodium, potassium is number 19. It can give out 1 electron. We have done that one earlier. In case if you missed that videos, but I've mentioned it here also. But in case if you miss, or if you want to know knowledge of how to break down the element, kindly watch the videos under the chemical bonding. We have talked about a lot on that one. So now, so potassium is +1. That's going to be +1. But we can see it has 2 times 2 plus. So this is Cr, which is chromium. We have Cr then times 2. Because in this case, each element has their own subscript. Potassium has its own subscript. Chromium has its own subscript. At the same time, oxygen too also have its own subscript. So potassium is +1, then times 2. That's the first one. Chromium is what I'm looking for, times 2, then plus oxygen is a -2 times 7. Everything is equal to 0. So now 1 times 2, of course, we are going to have 2. Then Cr times 2, we are going to have 2Cr -2 times 14, times 7, we are going to have -14 is equal to 0. So now, let's rearrange this one. I can have plus 2Cr. You can see this is +2 -14. Of course, we are going to have -12 is equal to 0. So if I collect like time, this is negative. When the minus goes here, we are going to have positive. So that means that we have 2Cr is equal to 0 plus 12. Then we have 2Cr is equal to 12 by 2. Because what I'm looking for is Cr, not 2Cr. So the number we have beside that Cr is 2. Then we divide all through by 2. Then we can have Cr here to be How many 2 can we get in 12? Then we are going to have 6. So how are we going to name that? Let's see how we are going to name that. Remember, if we have 7 oxygen is the same thing as what? It's the same thing as hepta, because the number of the oxygen you have in a compound determine the structure. That is it going to be tri, is it going to be tetra, is it going to be penta, hexa, hepta, or nona, or whatsoever. So you'll be checking the number of the oxygen you have in that particular compound. But here, we can see what we have there is 7. So since we have 7, that means we are going to make use of what? Hepta. So now let's name it. So let's name the compound now. So now to name that, K is potassium. That's going to be potassium. Now, so I told you the one that you determine will be the last one. Then we name it like this. Oxygen for O7. That's a hepta, So I told you when they are in the middle, they will change their name. So since we have chromium, it's going to turn to what now? Yeah, chromate. So that's going to be chromate. What do we have? We got 6. That's going to be chromate 6. That is our potassium heptaozo chromate what? Chromate 6. That's all about naming of compounds. When you want to name a compound, the most important thing is to firstly find its oxidation numbers, then you can be able to name the compound. Now, let's now go to balancing or redox reaction. So, we have talked about how to identify the charges of each element, either they are metals, either they are non-metals, or either they are noble gas or metalloid. So, for the oxidation, is the loss of electrons, reduction is the gaining of electrons. But in general, if they want to define it, you can say one is adding hydrogen, the other one is losing oxygen. So, but in terms of electron transfer, this one is losing electrons, while the other one is what? Is loss of electron, then gaining of electrons. So in balanced redox reactions, we'll be checking the electrons. Note one thing, we can only subtract electrons, we cannot add electrons. Just like a vice versa. You will check at the reactant side that how many electrons do we have there. Let's say in the reactant side, let's say I have 5 electrons. So I must also have 5 electrons on the other side too. If I have 0 electron here, of course, I must have 0 electron here. But how are we going to distinguish or differentiate between the two equations? That which one is going to be for oxidations and which one is going to be for reduction? This is the logic. Let's say I have A plus B to give C plus D. Let's say I add electron to this side. Normally we know this side is called reactant, while this one is called product. In any situation, if we add electron to the product side, you can see here, I add it to the product side, isn't it? When we add electron to the product side, such equation is called oxidation. It can never be changed. You can see that when we add electron to the product side, but in a situation whereby which if I add electron to the reactant side, like this case, you can see where we have electron is this side. So whenever we add electron to this side, that one is called reduction. So please, you have to master this logic. If I add electron to the reactant side, it's reductions. If I add electron to the product side, it's called oxidation. What are we trying to say in essence? Let's say I have equation like this, for example. Maybe I was asked to balance this. So how can I balance this? This is iron. So you can see here, how many iron do we have here? We have 3 iron. This is plus 3. And here we have 2. This is plus 2. Are they balanced? Yeah. So how many? Which side do we need to subtract? Yeah, we need to subtract. How many do we need to subtract it to make it balance? Yeah, 1. Because here we have 2. Here we have 3. Meaning, if I was able to subtract 1 here, it can be able to balance. So that means we have iron 3 plus 1 electron minus to give iron 2 plus. I told you, if you subtract electron from this side, such reaction is called what? It's called reduction. Can you see that? Now, okay, let's see for the lead. Let's see for the lead. Let's see for the lead. Just give you general examples. So here you can see, do we have any electron here? So now this is 0. Do we have any electron here? Yes, of course we have. But are they balanced? So they are not balanced. So I need to subtract electron from here. How many did I need to subtract from here? I need to subtract 2 since this one does not have any electron. So that means that we have lead give lead 2 plus plus 2 electron minus. So whenever we separate electron from here, such equation is called what? It's called oxidation. You can see that. For the reactant side, it's called reduction. For the product side, it's called oxidation. So let's give a general example. Let's give one example. We ask to balance half-life equations. We call it half-life equation. Let's balance this one. We just say balance, write a half-life equation for, write a half-life balance redox reaction for, let me just give you general examples. Let's just give an example. Maybe they said aluminum 3 plus plus lead. Let's see these examples. And see how we are going to approach that. This single remove. So they're border. So now this is the first equation. So we have to balance this. We have to balance this one. One for oxidation, one for reduction, and write the general equation there. So what I will do, I will firstly break it down into two. Aluminium for aluminium and lead for lead. Can you see that? So I will firstly bring that one. That is Al3 plus to that of Al. That's the first one. Then Pb to that of Pb2 plus. So now the 2 plus. Now let's balance for the first one and for the second one as well. So here we have plus 3. Here we have 0. So now we can see that the two sides are not balanced because here is 3 electrons and here is 0 electrons. So which side do we need to subtract electrons? Yeah, this side, because these are the 0. So that means that we have Al3 plus 3 electrons to give Al. Can you see that? By the time 3 minus 3, that's going to be 0. So when we subtract the electron from here, as I mentioned earlier, it's called reduction. Okay? Let's go to this side. So here is 0, here is 2. Are they balanced? So I need to subtract from here too. That means that we have lead, then lead 2 plus 2 electron minus. So since we subtract electron from here, this is called oxidation. Can you see that? So this is reductions and this is oxidation. So let's bring out the two. The first one we have Al. This is for reductions, right? For oxidation we have Pb. So now, how will I go with that? So here we subtract 3. That means I have to multiply this by 3. So here we subtract 2. We have to just like you are doing simultaneous equation. The number of electrons you subtract from the first one, you use to multiply the second one. The number of the ones you subtract from the second one, you use to multiply the first one. So 2 times this, we have 2 Al3 plus. 2 times 3, we have 6 electron minus. 2 times Al, we are going to have 2 Al. So 3 times lead, you are going to have 3 lead to give 3 times this, we have 3 Pb2 plus. Then 3 times 2, we are going to have 6 electron minus. Can you see that? So I will now add the one at the reactant together and the one at the product. You can see this is the one we have at the reactant side and this is the one we have at the product side. So if I do that, so here we have 2 Al3 plus 6 electron minus plus 3 lead. You can see 1, 2, 3. Then for the product side, we have 2Al plus 3Pb 2 plus 6 electron minus. So you can see here we have 6 electrons. Can you see that? Here we have 6 electrons. You can cancel each other. So if they cancel, we left 2Al 3 plus 3 lead 2Al plus 3Pb 2 plus. That's all about that one. Then let's solve more examples. Just the same thing. In any problem, firstly factor out the one for oxidation, one for reductions, then after that one you balance it. But in the case of negative, that's another issue. Let me just break it down. For the negative, when we have a negative, let's see how we're going to do that. When we have a negative, like chlorine, let's say we have chlorine gas. For example, in general, let's say I have something like this. You see this one? I have to firstly balance in terms of electron first. Here I have 2 electrons, so I have to balance it first now. You can see now, here is 0 now. Yeah, this is 2 electrons. 2 mole of chlorine, 2 mole of chlorine now, so it's balanced now. So the next step is to balance them in terms of electron. So here we have 0 electron, and here we have minus 2 electron. So did I need to if I'm adding 2 to this side as well, that means I will doubling it, I will adding it. So I have to subtract 2 here for also, so that I can be able to have the same thing. So that means we have chlorine gas plus 2 electron minus to give 2 chlorine minus. You can see it's balanced now. This is minus 2 and this is also minus 2, which is balances. I hope you get it right. Are you following? Yeah. So let's balance another one, the one that comes in form of water, that we need to add water to that one. This one minus 4 minus. Let's say we have something like this. In this case, in this type of balancing of redox, the first thing we need to do is you can see in this side we have oxygen and here there's no oxygen. So when we have a problem like this, the first thing to consider is to firstly add water to the side without oxygen. So how? So you can see this side there's no oxygen, so I will add oxygen to this side. So that means here we add water rather. So here we have MnO4 minus to give Mn2 plus H2O. That's the first step. When we are balancing redox reactions, in this case, you will check the side which one does not have oxygen, then you add water. So now, let them balance the times of oxygen that we have. You can see here I have 4 oxygen, but here we have 1. So if I balance it, now I have 4 oxygen. But the moment we have 4, it affected hydrogen. Hydrogen has become how many now? So because 4 times 2, we are going to have 8, right? So that means now we have MnO4 minus to give, so we had it here, plus 8 hydrogen plus to give Mn2 plus 4 H2O. So here is minus 1, that is minus 1. Here is plus 8 times 1, we are going to have plus 8. Here is plus 2, and here is 0 because there's no charges here. So minus 1 plus 8, that's going to be plus 7. Plus 2 plus 0, that's going to be plus 2. Are they balanced? Of course they are not, because here is 7 electrons, here is 2. So how many did I need to subtract, and which side? Yeah, the reactant side I need to subtract how many? 5. So here I can have MnO4 minus plus 8 hydrogen plus 5 electron minus to give Mn2 plus 4 H2O. So here you can see I have minus 1 here, here I have plus 8, here we have, it is balanced already. You can see here I have minus 5, here we have 2, and here we have 0. Can we check? So minus 1 plus 8, of course, we have 7. 7 minus 5, we are going to have 2, which is equivalent to what we have at the product side. So in the case of this, the first thing to consider, firstly add the oxygen to this water to the side without oxygen. Okay, let's just pick one. Let's assumptions. Let's just make one examples. Maybe I was asked to balance this one. Cr07 2 minus plus iron 2 plus Cr3 plus iron 3 plus. Maybe I was asked to balance this. Chromium, Cr072 minus plus iron 2 plus to give Cr3 plus plus iron 3 plus. So I told you the first thing is to break the tie, chromium for chromium, at the same time, iron for iron. This chromium for chromium, iron for iron. So that is Cr072 minus Cr3 plus. Now the other one is iron 2 plus iron 3 plus here. So now I want to break down the two. So here you can see here there's oxygen, but here there's no oxygen. What did I need to have to this side? Water. So that means that we have Cr072 minus Cr3 plus plus H2O. So now here we have minus 2, or before that, here I have 7 oxygen, but here how many oxygen do we have here? So I need to add 7 here. If I add 7, so it has become 7 oxygen. But hydrogen has become what now? 7 times 2. What are we going to have? 14. So that means that we have Cr072 minus plus 14 hydrogen plus to give Cr3 plus plus 7 H2O. Here is minus 2. Here is 14. Here is 3. Here is 0. Can you see that? So minus 2 plus 14, we are going to have plus 12. Here we are going to have plus 3. Are they balanced? So that means we need to subtract how many? 9. That's going to be Cr72 minus 14 hydrogen plus 9 electron minus Cr3 plus plus 7 water. Can you see that? No, it's 9 because this is 12, this is 3. So that means if you remove 9 from here, balance with this one. I told you, whenever you subtract electron from here, such reaction is called reduction. So now, the second part now. So we have iron 2 plus, iron 3 plus. You can see here is plus 2, here is plus 3. Are they balanced? So which side do you need to subtract electrons? Yeah, to your side. That means that we have, and how many? Subtract 1. Because this is 2, this is 3. You know, if I subtract 1 from here, it's going to become 2 as well. So that means that we have iron 2 plus, iron 3 plus plus 1 electron minus. And we know if you subtract electron from here, such reaction is called oxidation. So now we subtract 3, we subtract 9 here, this is going to be times 9. We subtract 1 here, this is going to be times 1. Right? So you know, if I multiply all this value by 1, I will still have this. So but 9 times this, we are going to have 9 iron 2 plus 9 times this, and we have 9 iron 3 plus, then 9 electron minus. So now the next step is to add them together. The one we have at the reactant and the one we have at the product. So these are the one we have at reactant. We have Cr072 minus plus 14 hydrogen plus plus 9 electron minus plus 9 iron 2 plus plus Cr3 plus, you can see, can you see that? Plus 7 water plus okay, sorry, 1 2 3. Oh, this is supposed to be this. So the one at the product, this one and this one. Nine iron 3 plus plus 9 electron minus. So they can cancel, you can see they are the same now and then. What we have left is Cr072 minus oxygen plus 9 iron 2 plus Cr3 plus plus 7 water plus 9 iron 3 plus. So that's what we have for this. So that's what we have for this balance of redox reactions. So please don't forget to like our videos, share so that other too can be able to benefit from this tutorial. This is Made Easy Academy. So thanks for watching.